Okay, so here we go with dilations. Dilations is the one that really hurt us last year, and it's just a complicated thing for the kids to pick up. But the bottom line is a dilation is taking a figure and either making it bigger or smaller. And a lot of kids think that on the graph, if you have a triangle, that it's going to kind of do the accordion effect where it'll get bigger like this. That's not what happens. It actually moves out away from the graph. So if I have a triangle like this point is going to move out, this point is going to move further out, and this point is going to move further out to where it looks like the same shape. Well, it's supposed to, but that's the general idea, is they're moving away from the origin. They're not moving around the triangle, and I'll show you what I'm talking about here. So this is triangle ABC. They say dilate it by a scale factor of 2. So the first thing you have to do is identify all your coordinates. So A is going to be at 3, 3, it looks like. B is at 3, 1. C is at 1, 1. So those are our coordinates for A, B, and C. So A prime, B prime, C prime, in other words, our new transformation, our new dilation, the new shape, is just going to be all of these coordinates multiplied by 2. So 3 times 2 it'll be 6, 6. 3 times 2, it'll be 6, and 1 times 2 is 2, and then the other one will be 2, 2. So all I did was take all of our original coordinates and multiply them by 2. And now I'll graph the new coordinates. So C prime is now going to be at 2, 2. That's C prime. B prime is going to be at 6, 2. 1, 2, 3, 4, 5, 6. 1, 2. And then A prime will be at 6. 1, 2, 3, 6. And so my new triangle now looks like this. And like I said, it's not going to get bigger around the triangle. It's not going to do the accordion effect. What it's going to do is it's going to move away from the axis. I mean, from the origin. I'm sorry, from the origin. Which, remember, the origin is the center. So all dilations are similar figures, which means they're the same shape, they're just a different size. You can see this is still a right triangle. If I did it right, did I go up enough? 1, 2, 3, 4. 1, 2, 3, 4. Yeah. So triangle ABC has been dilated by a scale factor of 2 to form triangle ABC prime. So same thing like with the translations and reflections. They can either give you a picture on a graph, and then each answer choice will be a picture of a graph. And so our original picture would be the pink triangle, and the right answer would be the blue triangle. The second thing they can do is they can say, hey, dilate triangle ABC by a scale factor of 2 and give the new coordinates for A. Well, that would be 6, 6. The other thing they can do is they can ask for the rule. Now, the rules with dilations aren't too bad. The bottom line is, what did we do to all the x's and all the y's? We just multiplied them by 2. And remember, anytime you have a number next to a variable, that means multiply. So this says 2 times x and 2 times y. And that's what we did. So that's basically how a dilation works. And remember, you have two kind of dilations. You have an enlargement or you have a reduction. The enlargement would be a number that, if the scale factor is above 1, a number that's above 1. A reduction would be when the scale factor is a number that's less than 1. So if you had a scale factor of, let's say, 1/2, 1/2 is certainly less than 1, so that would be a reduction. If your scale factor is above 1, let's say it's 2 3/4, 2 3/4 is obviously above 1, so that would be an enlargement. Okay? And that's dilations. Now, of course, it gets complicated when they give you fractions and things like that, but we do have the calculator, so just make sure that you use the calculator and we should be fine.